Well, welcome back. In this lesson, we're going to talk specifically about rates of change. And a rate of change, we've talked about in our last lesson, is a description of how one quantity changes with another. So remember, our rates of change have different units, whereas our ratios oftentimes have the same units. So we want to make sure to differentiate that rate of change is different from a ratio because the units are always different in a rate of change. Some examples that we've talked about with rates of change are like miles per hour, um, miles per gallon when you're talking about your car, the amount of pay that you earn, dollars per hour, things like that. So our objectives for this lesson, we're going to be able to find rates of change, and we're going to describe those rates of change by telling whether they're increasing or decreasing, or whether they're staying constant and not changing at all. So here's an example. Alicia had 62 entries in her email contact list at the end of 2007. Use the information from the table to find the rate of change in the number of entries in her email contact list between 2004 and 2007. So we're trying to find the rate of change. So we're going to find how many entries she had changed. So the number of entries, how that quantity changed compared to the number of years that went by. So what we're going to do is we're going to take the number of entries, 62, and subtract it from the previous number of entries, which was 10, and then take the years and subtract those. So 62 minus 10 is 52, and a time of 3 years had elapsed. So her rate of change, remember this is like a unit rate, is 17 entries per year on average. Here's another table that shows Ramon's height at age 8 and 11. Find the rate of change in his height between the ages. So remember, you're going to take the difference, 58 minus 51, and 11 minus 8, and we're going to find that rate of change. So 58 minus 51 gives us 7 divided by 3. So our rate of change as a unit rate then, what would that be as a unit rate? 7 divided by 3 is 2.3. And what are our units? Oh, we don't have our units. I'm assuming these are inches per year. Okay, 2.3 inches per year roughly. Rates of change can be positive, they can be negative, or they can be constant. So a positive change, rate of change, a positive rate of change slants upward. Okay, you can think of that if you have your northeast, south, and west directions. It's a northeasterly direction. A negative change slants downward. So as time goes on, if time were on your x-axis, it goes downward. It's getting smaller. And zero rate of change, or no change, is just a horizontal line. We don't have a rate of change that would be a vertical line. That wouldn't make any sense. Or maybe it would be an infinite rate of change. It would be not measurable. So let's find a negative rate of change. Here's a graph, and it shows the average cost of personal computers from 1998 to the year 2002. I know that's kind of covered up right there. It's a 2002. Find the rate of change in cost between 1998, so that would be this 1300 data point, and the year 2000, which is the 1000 data point, and describe how the rate is shown on the graph. Well, what kind of a slope is that showing? Is it going up or is it going down? And it looks like it's going down, so we need a table. So 1998, the cost was $1,300. The year 2000, the cost was $1,000. So the difference in the cost was 300 bucks. And it looks like I'm going to have a little issue here because I added a text box in there, so that should help. So that difference was 300. It went down 300, but the year went up by 2, right? So our rate of change, we're going to take the negative 300 divided by 2, which gives us a minus $150 per year as our rate of change. So down below it says in the graph, find the rate of change between the year 2000 and 2002. So go ahead and pause the video and see if you can come up with the difference from 2000 to 2002. You're going to use the data point 1000 and 855. I'll give you the answer when you come back. All right, hope you took a chance to do that. the difference or the rate of change, again, it's still decreasing, it's going down. You should have received an answer or come up with an answer of $72.50 per year. In this graph, we have a number of internet users in the United States, and we want to compare the rate of change between 2002 and 2003 to the rate of change between 2003 and 2004. So here are our data points. For 2002, we had 158 million. For 2003, we had 161 million, and then we're going to compare that to the difference between 2003 and 2004. So using our data right here, these two coordinates, to find our rate of change, we're going to take 161 minus 158. Maybe it'll help to draw this in here. We're taking this number, the y coordinates, and subtracting them. And then we're just taking the years and subtracting those. Okay? So that gives us approximately 3 million per year. Is that going up or down? Well, it looks like it's going up, right? It's a positive slant, so it's 3 million per year. From 2003 to 2004, again, we're going to take the second number and subtract the first number. And when we do that, we get 190 minus 161 gives us 29, and it's still over 1 year, okay? So that gives us 29 million per year, which is a significant more change in that year than it was from 2002 to 2003. All right, in this example, you're to use the table to make a graph of the data and find out which 2-year period was the rate of change in oil production the greatest. So what I want you to do on this one, you're going to bring your answer to this one to class. I'm not going to do this one for you on the video, but I have set up your table or your graph for you. So I want oil production to go on the y-axis and the year to go on the x-axis. And you're going to put this data in here. You're going to plot all these points. So you'll have 1, 2, 3, 4, 5, 6 data points in there. And then go ahead and connect them, just like in the previous slides. Connect them. You'll have these dots. Connect them with lines between the dots. And then find out which year, during which 2-year period, these are all 2-year periods, which one has the steepest slope. Okay, which one's increasing the most? And bring that answer to class with you. See you next time.